Hello everyone. Welcome to today's video, where I'll be sharing something really exciting: how to create a dynamic hierarchy tree in Oracle Apex using dynamic content. This feature allows you to visualize hierarchical data effortlessly, whether it's an organizational structure, academic plans, or any relationship-based data. In this tutorial, I'll walk you through the entire process step by step, so you can implement it in your own projects with ease. If you're working with Oracle Apex and want to enhance your applications with dynamic visualizations, this video is for you. So, let's dive in and get started. First, I will create two essential tables, one for item categories and another for items. These tables will form the foundation for building the hierarchy tree. Now, I will create a foreign key relationship between the item table and the category table. This foreign key will establish a link between the items and their respective categories, ensuring data integrity. Now, I will set up a master detail form to enable input of item information based on categories. In this setup, the master grid will display and manage the category table, allowing me to view and edit the list of categories. The detail grid will display and manage the related item table, where I can add or modify items under each category. This approach ensures a seamless way to input and manage category-wise item information, all in one interface. I'll use Oracle Apex's interactive grid to implement this functionality, which makes the process efficient and user-friendly. Next, I will create two sequences, one for the category table and another for the item table. These sequences will automatically generate unique values for the primary keys whenever a new record is inserted. By using sequences, we can ensure that the category underscore ID in the category table is always unique. The item underscore ID in the item table is also unique. This approach simplifies the process of managing primary keys and avoids manual entry errors. Now, I will insert some sample data into the category table to define item categories. Once the categories are created, I will insert related items into the item table under each category. This process will help build the hierarchy tree, as each item will be associated with a specific category. Now, I will create a dynamic content region in Oracle Apex to display the hierarchy tree. This dynamic content will use SQL queries to fetch data from the category and item tables and organize it in a parent-child structure. I've declared a CLOB variable, v_html, to store the HTML structure for the tree. I'm also using a recursive procedure named build_tree, which takes a parent_ID as input. This procedure fetches data for each category and its related items and then appends the corresponding HTML to v_html. In this section of the procedure, I am fetching all child categories for a given parent category using a for loop. This loop processes all child categories for the current parent and builds their corresponding tree nodes dynamically. In this section of the loop, I am building the HTML structure for each category dynamically. First, the category is added as a li element with a unique data category ID attribute using CT_ID. In this part of the loop, I am fetching items that belong directly to the current category using another query. The query selects item_name, item_ID, and item_NO from the in_item table. It ensures proper mapping by filtering items where CT_ID matches the current category's CT_ID. The items are ordered by item_NO and item_ID for consistency. The build_tree procedure is called again with the current category's CT_ID, allowing it to fetch and process any subcategories. After completing the recursive call, the alt tag for the child categories is closed, ensuring proper nesting in the HTML structure. Finally, the li tag for the current category is closed. In this section, I'm initializing and finalizing the HTML structure for the hierarchy tree. First, the HTML begins with a root all element with an ID of category tree. The build_tree procedure is called with 0 to start building the tree from root categories, or parent_code is null or 0. Once the recursive procedure completes, the root all tag is closed, finalizing the tree. Finally, the full HTML content stored in v_HTML is returned. Now, I will execute the pl/SQL block to generate the dynamic hierarchy tree. We can see that the tree has been successfully generated, displaying items under their respective categories. Now, to make the tree more visually appealing, I'll apply some CSS styling. I've now applied custom CSS styling to enhance the look and feel of the hierarchy tree. This makes the tree more interactive and visually organized. If you'd like to learn more about the CSS code I used and how it works, you can visit my blog for a detailed explanation. The blog includes step-by-step guidance and the full CSS code you can implement in your own projects. The tree looks great, but we've noticed that clicking on a parent node doesn't trigger any action. To fix this, we need to implement a small JavaScript code. In this JavaScript code, I've added functionality to expand/collapse categories with toggle buttons, expand or collapse all categories with dedicated buttons, and a search feature to filter tree items dynamically. For a detailed explanation and the full code, visit my blog. The hierarchy tree is now working perfectly. Next, I'll add a search field to quickly filter and find specific items or categories. Additionally, I'll include expand all and collapse all buttons to allow users to expand or collapse the entire tree with a single click. These features will make the tree even more interactive and user-friendly. In this HTML code, I've added a search bar and 2 buttons for better tree functionality. Search bar: this input field allows users to search for specific categories or items in the tree. It includes a placeholder text with a search icon and a clear button, heavy multiplication X, to reset the search. Expand all and collapse all buttons: these buttons provide quick access to expand or collapse the entire hierarchy tree. Each button is styled with gradients, rounded corners, and shadow effects for a modern look. We can now see that the expand all and collapse all buttons, along with the search field, have appeared on the interface. First, I'll click the collapse all button. Perfect. The tree collapses as expected. Now, let's test the search functionality. I'll type a keyword into the search bar to see if it filters the tree correctly. As we can see, the search is working perfectly. Thank you for watching. I hope you found this video helpful and informative. If you have any specific topics you'd like me to cover in future videos, feel free to let me know in the comments section below. All the code and examples demonstrated in this video are available on my GitHub repository. I'll include the link in the video description for your convenience. Don't forget to check it out. If you enjoyed this video, please like, share, and subscribe to support the channel. Your feedback and suggestions are always welcome and help me create better content for you. See you in the next video.